So today was 7-3, day 2, example 5. Yesterday we entered this augmented matrix into our calculator, and maybe I didn't enter it in here. I thought I did. You should have 1, 1, 1, 3, 2, 1, 4, 8, 1, 2, negative 1, 1 in a spot in your calculator. And when I did mine, I placed this matrix in the B spot. I know I'm going to use A for my notation just out of habit. You know, A and B are used a lot, so we'll make the adjustment as we go today. I want you to be able to find the reduced row echelon form matrix here. So when you enter into your calculator, I've got mine sitting in matrix B, I believe. So I'm going to go in and go after my matrix. Maybe I'm going to go after my matrix. First, let's take care of the board because it's not doing what it's supposed to do. Possibly. There we go. Okay, so now second matrix, and we're sitting at B, so let's go to 2. And what are we doing with the 2? Oh, we're supposed to do reduce row echelon form, so I'm going to pop that back, and I'm going to go insert, second matrix, go to math, and I'm going to go to my reduced row echelon form, which is B here. Okay, enter, and hit enter. And that should kick out my 1, 0, 3, 5, 0, 1, negative 2, negative 2, 0, 0, 0. Are you guys okay with that and able to do that with your calculator? Okay. Now in the reduced row echelon form, we should have the same matrices. In the row echelon form, it doesn't necessarily mean that we'll have the same answer for our matrix, but when we finally look for our variables, they should be the same variables. So I've got that 0, 1. So I've got my matrix coming out of here, and I just wanted to put that in there. That's what we were going to find, so I got that done. And I'm just going to write down what I got, my reduced row echelon form, because I want to make sure you guys see where I'm getting all my values. So when I do this, I've got this going on, negative 2, 0, and that's a 5, negative 2, 0. At least I think it's a 5. Excuse me. Oh, yeah, good. Good for us. Now, here's the deal. This is what this means when I'm done. Remember, my letters were X, Y, Z. So this is my X row, my Y row, my Z row, and then my answer row. So when I'm answering this, I've got the actual equation X plus 3Z equal 5. And then I've got Y. My second row comes into Y minus 2Z equal negative 2. Okay. I want you to be aware that I'm going to find what X would actually equal. Okay, so X would actually equal, if I solve just for X is equal to negative 3Z plus 5. Okay, Y would actually equal, Y equal 2Z minus 2. Are you okay with that? And how I got it? Yes, no, maybe? Now, when I'm going to house my answer, I've got a solution set of the ordered triple. So I've got my solution set, which is my X, Y, and Z, where X is negative 3Z plus 5. Y is 2Z minus 2, and Z is just itself. Okay, this is infinite solutions. Okay, where Z is contained in the real numbers. Okay, so it can be any real number, Z can. So you got 4, that's a solution. You got 8, that's a solution. You got negative 12, that's a solution. So we've housed and defined what X, Y, and Z are. Yeah.
So why didn't you have to take the Z out?
Why didn't I have to take the Z out? What do you mean by?
The X equation and the Y equation.
Oh, I didn't because that X and Y are defined in terms of Z.
Okay.
Okay, now keep in mind one of the reasons why we're able to do this. This is infinitely many solutions because it's 0 equals 0. If it was 0 equal 4, it would be no solution situation. Okay, but because it's 0 equals 0 and z can be any value, okay, and so z fell out of our solution and there's infinitely many solutions as we go. So now x and y are both defined in terms of z, and z can be any real value. Okay, what I'd like you guys to try is do example 6. And I have the reduced row echelon form there for you already. Actually, that was there for that reduced row echelon form, and we'll just go right to it. I've got the reduced row echelon form there. It's more important for me, for you to practice what to do in the solution when you're given these. And this is a ZW situation where Z and W are any real number. So again, my original matrix that I put in before my row echelon, my reduced matrix is going to be 1, 2, negative 3, 0, negative 1, and 2, 3, negative 4, 1, negative 1, and 3, 5, negative 7, 1, negative 2. So that's the original matrix I work with when I pop this in. Okay, that's what I'm going to put in my calculator. Okay, and I'm going to put it in RREF. And I should get kicked out this reduced row echelon form matrix. Okay, are there questions about the calculator use, about being able to do this? Now, you will have something like this on the test. You will be expected to reference your infinitely many solutions in terms of the variables that dropped out, like defining x and y in this case, in terms of z and w. So be aware of that. So there are infinitely many solutions. 0 equals 0. If it was 0 equals some other bogus number, it wouldn't be a solution at all. Okay, but we're talking about the fact that I've got my x plus 2y minus 3z, and then there's no w, equal negative 1. That's 1. That's row 1. Row 2 is 2x plus 3y minus 4z plus w equals negative 1. Okay, as I'm stepping through. Make sure I've got that written down there the way I want it. X, Y, Z, W. Oh, I'm sorry, I'm doing the wrong thing. I've got that. I'm not even working with my reduced row echelon. I was like, that's not what I'm doing. Okay, so worried about getting it right. X, we've got that going on. That's my X, my Y, my Z, my W columns. So keep that in mind. I've got X plus Z plus 2W equal 1. That's my first one I'm going to do. And my second one, my second row is going to be Y minus 2Z minus W equal negative 1. And my third one is just going to be the fact that I know that Z is equal to Z and W is equal to W. Okay? And Z and W will be any real numbers as I step through this. I'm going to solve X in terms of Z and W. Okay, that's the first thing I'm going to do. So when I do that, X is equal to, well, negative Z minus 2W plus 1. And I'm going to solve for Y. Y is equal to 2Z plus W minus 1. And again, when I house this as a triple, do it in this solution. Okay, X, Y, Z, and then W equals for X, negative Z minus 2W plus 1. My Y, 2Z plus W minus 1. And remember, I wrote Z and W equal to themselves. Okay, where Z and W are contained in the real sets of numbers. Okay, as I go through. Questions about that at all? Remember, this is an infinite number of solutions. As we get that down, I should make sure I get that. Yeah.
Did you know the W is equal to W?
We make that, we take that assumption as we go through. They're going to be equal to themselves, and whatever values you come up with, W and for Z and W, we will define X and Y in terms of those values. So that's why whatever you can think of for W and whatever somebody else can think of for Z, it's going to totally work all the time. Okay, that's what we're saying in this situation. Okay, does that help with that clarification for the infinite? Now, these are unique, but you will have them come across your wake on the assignment, and it's always when that bottom one's going to be zeros. Okay, and remember, as we go through, as you read that reduced row echelon form matrix, that bottom one or the bottom two, depending on what your relationships are, 0 equals 0 is an infinite number. 0 equals something, something else, we're going to have a no solution situation. Any other clarifications? We're okay with thinking around with reduced row echelon form, being able to define your matrices, being able to get it in, because you don't have to put them in reduced row echelon form by hand. You get to use the calculator, okay, when it's not a 2x2. Okay, now let's talk about solving skills as we go through. In order to solve, if solving systems with inverse matrices, this inverse matrix solving is kind of fun to do. If a linear system consists of the same number of equations and variables, then the coefficient matrix is a square. And remember, I can only solve using an inverse operation with a square matrix, okay, because we can only find the inverse of a square matrix. Okay, so if this matrix is also non-singular, the determinant's not equal to 0, then we can solve the system using the inverse. Okay, and I'll talk about why here. When I find the inverse, remember the inverse of a matrix, and maybe I should do it like this. If I have A, B, C, D like this, its inverse is AD minus BC on the bottom. And then D and A switch position, and we take the opposite of the B and C terms, okay? So when we're doing this inverse, this is what I've got to do to get to my inverse of A. So we're going to define A, and then we're going to do the inverse of A, and then we're going to talk about what B is as well. But I'm using this inverse skill to help me with my inverse of A. And we need to be able to do this by hand as we go through these. Okay, no calculator. You can check it with your calculator while you're doing the assignments, but on the test there will be a no calculator portion of it. So on this, I'm going to define matrix A as 3, -2, -1, 1. Okay, I've got matrix X, which is just my unknowns, which is X, Y. Okay, and I also have a matrix B. Okay, and that's 0, 5. So if I wanted to, I could represent this in symbols as A, X equal B. Okay, and as you go through, you got to remember, maybe what I'll do is we could represent that. I want to write out the matrix first so you guys see where everything would go to become the formulas or the things we started with. Keep in mind, I just took those two equations and transferred them into matrix A, matrix X, and matrix B. So matrix A times matrix X is 3x minus 2y equals 0 for my situation that I've got. If I wanted to put it in there, this is A, X equal B. If I wanted to solve for X, what would be my next step? Wouldn't I just divide by A? And that's where my inverse matrix comes in. So I'm going to take the inverse of matrix A and multiply it on both sides to find my value where X is equal to the inverse matrix of A times B. So that's what we're going to do. Okay, remember the inverse of matrix A is 1 over A. So in finding the inverse of matrix A, I gave you the formula, basically what we're going to use, 3 minus 2, so I got 1. And this is finding the inverse of matrix A right here. And I've got 3 and 1 are going to switch positions. 1 and 2 take their opposites. And this becomes 1 times 1, 2, 1, 3. So my scalar becomes 1. Do you see that's going to be 1 as I follow through for my inverse? Yes or no? This 1 over AD, this portion, is right here for my inverse. And then I switched my matrix the way it was supposed to. So I got 1, 2, 1, 3 times 1. That's my scalar. So I'm not going to change anything. So in my calculator, or not my calculator, my next step I'm going to use, I've got my matrix A, which is my inverse of matrix A, 1, 1, 2, 3, times my matrix B, which is 0, 5. And now I'm just do my multiplication. I got 10, and I got 15. And it's not a fraction. It's 10, 15. And that's my X and Y values, okay, as I step through. Now, keep in mind what I did. I have matrix A times my X times B, okay? We can make that a little smaller there. Maybe group that whole thing there as we go over. Okay, so we pull that up out of the way. I'm multiplying by the inverse of A that I found right here. This is my inverse of A according to that formula. Questions about the inverse? I'm going to step through to make sure that you've got it. The inverse has a scalar, AD minus BC. AD minus BC, remember, when I went through this, I got 3, 1, negative 1, 2, and so AD minus BC is just going to give us that 3 minus 2, which is 1. Okay, that should be a scalar as we step through, and we go ahead and multiply that out as we get there. But that's the formula to find our inverse. Are there any questions about it? Then you'll be asked to do it a couple times today during the assignment. So now, after we get that inverse, we just multiply it by the answer. You don't even have to show this. I wanted to make sure that, hey, I'm just taking A, dividing by A. B divided by A is going to equal my X, 10, 15. Okay, so I know X here is 10 and Y is 15. And those are my answers. How did I get that done? Follow-ups. The next one is a 3 by 3 we get to use a calculator for. Okay, any questions about where I got my numbers? Now, doing the same thing, except with a, you get your coefficient matrix, first thing you do. Coefficient matrix is everything on the left side. That's our matrix A, okay, that we're working with. We have a matrix X that has the variables. They are vertical, X, Y, and Z. We have a matrix B. I'm just going to go across the top. 20, 40, 30. Those are matrices I already have in my calculator. So remember, the original is AX equal B. What I'm going to do, I'm going to multiply by my inverse matrix. And remember, when I do that, I get the identity matrix. So X is equal to the inverse of A times matrix B. So when I put it in my calculator, it's exactly what I do. I put in the inverse of A times B. And I have this matrix in C, so lied. I had it in matrix E. So second matrix, excuse me. Okay. So I've got this as my E matrix for A, enter. And I'm going to take my inverse. Okay, that's all I'm doing. And I put the B matrix in for F. So I'm going to go second matrix again. And I'm down there at 6. It's my 2 by 2. And I hit my enter. And those are my solutions as I step through. Okay, so once I get the general gist of it and I know what I'm doing, these are very fast problems. Okay, as we get going. So I got my solution here, and I'm just going to slide this up and this over because I've got that solution there. That's my 18, 39.33, and 14. So keep in mind, my x is 18. My y is 39 and a third, and my z is 14 when I'm done. Questions about doing it? Check your calculator right now. Make sure you can do this because you're going to do the next one. Actually, that's 9. I want to make sure you can do this one on your calculator. So put it in and see what's going on. Put this matrix in. Put your B matrix in. I want to make sure you can function in the calculator environment. Okay? Knowing that it's possible isn't great unless you can actually interface with your calculator and get it done. Okay? These are slick as you're going through. Yeah. Make sure you can do that. Put them in. Okay? Questions about entering. Okay, because this being able to do this with the 3x3s, the 4x4s, remember, there has to be a square coefficient matrix. Coefficient matrix is all the coefficients in front of the x, y, z, whatever variable we have on the left side. Coefficient matrix. The augmented matrix includes everything in the matrix. Okay, the coefficient is just the numbers with the variables. Has to be square and able to do the inverse. I've had a lot of people in the past try to solve this and they weren't working with a square matrix. Okay, so be aware of that, even though that they are worn the same way. It must be a 3x3, a 4x4, a 2x2 in order to use the inverse of a matrix. It's got to be a square matrix. Otherwise you can't use the inverse. You can't find it. Questions about it? It's got to be a non-singular matrix where the determinant's not 0, okay? And you'd know that right away at the beginning when we're setting it up on a 2x2 when you're doing it by hand, because if it's 1/0, you can't do it. You can't solve it that way. You got to do it a different way, okay? Questions? All right, now, what's the use on this? Determine A, B, and C so that points -1, 5, 2, -1, 3, 13 are on the graph of f of x equal ax squared plus bx plus c. Okay, we have 3 relationships here already. Okay, so any 3 non-collinear points with distinct x coordinates determine exactly one second-degree polynomial. The graph of the second-degree polynomial is parabola, so it's just going to be either up or it's down. But keep in mind, I gave you an x and a y combination, and I gave you 3 combinations of x and y. So how do we do this? Well, if I go f of -1, and I'm talking about a, -1 squared, plus b, -1, plus c, and this would return a 5. Are you okay where I got that relationship and where I found it? When I put -1 in for x, I get out a 5. Okay, well, I'm going to use this information to solve for A, B, and C. When I put in 2, I get out a -1. When I put in a 3, I get all 13. Okay, now keep in mind, I have a square coefficient matrix. I'm going to use that for myself, okay? And instead of stepping through, well, I can step through like that. I can set it up like this and get it to this situation. Are you in agreement that I can get it there because it's a square matrix? Okay, so now what I'm going to do is in my calculator, I'm going to have a coefficient matrix. So I'm going to have a coefficient matrix. In my calculator, I've got this as matrix G. So I'm still using A, but just keep in mind that's where the G comes in. But I've got a coefficient matrix of 1, -1, 1. Okay, that's my first row. Remember, it's A, B, C for my x's. My second one's 4, 2, 1. I got 9, 3, 1. And this is equal to 5, -1, 13. So that's my B. Are you okay with my B matrix and my A matrix and where I got them? Are there questions about B or A? We good? Okay, got head bobbles. Head bobbles is good. All right, now the next thing I'm going to do, remember I have this in for G and H. So I am going to do this function. This is my my A matrix. This is my X matrix, and this is my B matrix. Okay, so I'm just going to be running this relationship in my calculator. Okay, so clear this. You got the second matrix, and I'm sitting at G, which is 7. I'm going to do the inverse of G times second matrix, and I've got H, it's 8. Enter, and I get my answers. A is 4, B is -6, C is -5. Okay. So my return for X, I get 4, -6, and 5. And again, A is equal to 4, B is equal to -6, C is equal to 5. -5, thank you for catching me on that. Okay, and now I can write the actual quadratic, right? Because I have 4x squared minus 6x minus 5 is equal to my original function. Okay, and this will fit -1, 5, 2, -1, and 3, 15. I guarantee I have that on the test already. Okay, it's not going to be even a secret about it. And I expect the work shown on it. Not just an answer, but how do you want about it, okay? Questions to this point at all? Yeah.
What does it say underneath the quadratic?
This will fit. It'll fit those 3 points. Okay, the original, the question underneath quadratic, it will fit. It's not really a question, it's more of a statement. Of course, I'm not an English major like some people are capable of. Okay, we doing okay? Now, next thing is stepping through and looking at this solution problem. Aileen's drugstore needs to prepare a 60-liter mixture that is 40% acid. Now, keep in mind, that 0.4 times 60, the total amount of acid in here will be 24. Okay, that'll be total, like total acid concentration if it was 100% acid. And we're going to be using that in a little bit. using 3 concentrations of acid. Now, the first concentration is 15% acid, the second is 35% acid, and the third is 55% acid. Because of the amounts of acid solution on hand, they need to use twice as much 35% acid solution as 55% acid solution. How much of each solution should they use? Okay, now we've done this problem before. This is a little bit more involved because there's more relationships, so it's easier and opens itself up for us to use a matrix. Excuse me. Let X be the number of liters of 15% acid, Y the number of 35, and Z the number of 55. So first of all, these are in milliliters, and it's liters, and it's a 60-liter solution mixture, right? So this relationship is just X, Y, and Z must equal the total number of liters in the solution. So X, Y, and Z adding together must equal 60. That's our first relationship, okay? Now explaining how the equation of 0.15x plus 0.35y plus 0.55z comes in. Remember, I said that the total mixture will have 24, 24 pure liters of pure acid in it. Well, in order to get to this 24 number, we're going to combine these. So, and able to get there, the total amount of pure acid in liters, since the mixture must be 40% acid, is 0.4 times 60. Okay, that's where that number comes from. And that's about pure acid in the mixture. And the rest is just be a distilled water to thin it out. Now, they said in here, you need twice as much of 35% solution as the 55% solution. That's what's going on in step 3. Twice as much, okay? So as we're going through there, the number of liters of 35% acid solution must equal twice the number of the liters of the 55% solution. Sorry, I was doing that with the mouse, and it looked better in back on my computer. Right now, it really looks not so good. So let's fix that. Okay, I don't know why I'm trying. There we go, 55% solution. Now, write the system of 3 equations obtained from parts 1, 2, and 3 in the form of AX equal B, where A is the coefficient matrix of the system. What are A and B and X? And now this is for you. This is yours to solve. You have the 3 relationships, you have a square matrix, and you have the X matrix and the B matrix information. Go for it. So first write those equations down and write your A, X, and B matrix in. First write the equations down, and then write in your coefficient matrix, your X matrix, and your B matrix. It's our opportunity to fly on our own. See how we do. Remember, your A matrix should be composed of your X plus Y plus Z equals 60, or your 0.15X plus 0.35Y plus 0.55Z equal 24, and your Y equal 2Z, except we don't have the variables on either side of the equal sign. We have to get it to the left. Now, get your coefficient matrix. Remember, your coefficient is just the numbers in front of your X's. That's your A. Your X matrix should be X, Y, Z. Your B matrix should be what they're equal to. 60, 24, and 0. And people kind of like look at me at the 0, but think about what I have to do with Y equals 2Z to get the 2Z to the left. Are you okay with where everything came from? Just double check. You got A, you got X, you got B. Go for your solve. Put it in your calculator. Make sure you can do it. You'd have to time me on a loop on the scooter. That's going to be pretty cool. Everybody be like, what happened, Jared? Like, Bloom had a stopwatch on me. Okay, put it in your calculator. Make sure you can come up with the solution. You guys are doing a great job. They look great. Nice. Nice. Remember, when we set these matrices up, you got just as many as equations as unknowns. Okay? That's pretty much a pretty regular assumption as we go through. How'd you do? They look pretty good, the ones I was looking at. And then we have to debrief it and explain our answers. We don't just get, hey, it's 3.75, 37.5, and 18.75. It's, hey, X is 3.75 liters of 15% solution, and so on and so forth. And all are required to make the 60 liters of 40% solution. Yeah. Just gonna spin around here. Yeah.
I'm putting it in right, like I've checked it and
Let's just double check what
like I've put
was
everything
popped
in
in
the
there.
same way you did. That's
Yeah.
why.
0.1, 0.15.
Oh.
That should be a 0.35, not a negative. That should cover it once you fix that. Okay, I think, because the only negative up there was the 2. Okay. Is it good? And then it should be able, after you go back, hit second enter, and that'll like repeat the last string that you had, and it should take care of it. Any other quirky things with your calculators? Okay. Make sure you're getting stuff done. Tomorrow we're going to do partial fractions. It's something LaRue was really excited about when I was getting prepped for it. She goes, "You guys are going to do partial?" Well, it's okay, LaRue. It's not Christmas morning, but she was pumped. Okay, so where you've got partial fractions tomorrow, that's a lot of algebra manipulation by hand. Okay, I'm going to tell you the truth right up front on that. Okay, but have a great night. Hopefully everything's going well.